Hello students, welcome to EPG Pathshala. I am Professor Pankaj Madan from Faculty of Management Studies, Gurukul Kangdi Vishwavidyalaya at Haridwar. Today we are going to talk on the module Statistical Inference with two populations. Hypothesis techniques where we compare two sample tests or two populations. Under the paper, quantitative techniques for management decisions. After the completion of this module, the student will understand test for two population means independent samples, test for two population mean dependent samples, or two sample t-test, then hypothesis testing for difference between two means, or hypothesis testing for difference between means of small samples using pooled standard deviations, hypothesis testing for the difference between proportions and paired differences. This is a technique to test a claim to compare parameters from two populations. It can be explained with an example. Suppose an entrepreneur wants to open a new startup business and is contemplating of doing so in either two districts, business district 1 or business district 2. The economic affluence of a business district is the key in finalizing the entrepreneur decision. The entrepreneur wants to look at the household income as a key indicator of a business district's economic condition to settle the issue. Thus, from a statistical point of view, we are dealing with two populations. Population 1, that is a collection of household in the business district 1, and population 2, the collection of household in the business district 2. And the common variable which has to be studied in both the business district is the household income. So we compare the household income of population of business district 1 and business district 2. If an entrepreneur wants to compare the population in terms of mean household income, then the parameters of interest you may be knowing is mean household income of population 1, and we call it as mu1, and second parameter is mean household income of population 2, that is defined as mu2. First, one wants to know whether the populations are identical in terms of mean household income or not. To check this, one tests the null hypothesis. And what is that null hypothesis? HO mu1 is equal to mu2, means the mean household income of population 1 is equal to mean household income of population 2. Or you can also say that the null hypothesis is that there is no significant difference between the household income of district 1 and district 2. Then what will be the alternative hypothesis? The alternative hypothesis is HA or H1, that mu1 is not equal to mu2. The idea is that if HO is accepted, then it is concluded that the business districts are identical in terms of mean household income, and the business person can then focus on the secondary factor or the other factors like transportation, tax structure, etc. And he can say that the income, since the income is not the criteria for the difference, he may look for some other factors to make the final decision about his business. In the above null hypothesis, if in this example, if null hypothesis is rejected, or there is some other reason to believe that one population has higher mean than the other one, then you are inclined for making a different kind of null hypothesis, like mu1 is less than equal to mu2, against mu1 is greater than equal to mu2, or mu1 greater than equal to mu2 and the alternative of it will be mu1 is greater than mu2. If the entrepreneur wants to compare the population in terms of proportion, not in terms of mean, then the proportion of household having minimum income level, say k units per year, then parameters of interest would be P1. In the last we have seen mu1, here we have put P1, and P1 states the proportion of household income in population 1 having a minimum specified income, and P2 the proportion of household in population 2 having a minimum specified income. One can now check whether the population are identical or not in terms of proportion of household income having minimum specified income, and this can be done by testing. And what is to be tested? In which the null hypothesis is that proportion 1 is equal to proportion 2 against the alternative hypothesis P1 is not equal to P2. Depending upon the practicality, we can also make another type of hypothesis in which we can say that P1 is null hypothesis in which P1 is less than P2 against an alternative hypothesis where P1 is greater than P2, and we can make another hypothesis which is vice versa of this. We will test that the means of the two population who are the two independent samples, whether they are equal or not. So we say that it's a two population t-test. So for the two populations, say population 1 and population 2, let the mean of a common variable be mu1 and mu2 of population 1 and population 2 respectively, and they are also completely unknown. So our objective is to test that if mu1 is equal to mu2 against an alternative hypothesis where we can create three conditions stating that mu1 is greater than mu2, mu1 is less than mu2, or mu1 is not equal to mu2. So in this slide you have seen how we have created a hypothesis of the means for two population t-test. You can see that to test the above null hypothesis, random samples of size n1 and n2 are drawn from the above population, and the sample observations from one population are independent of those of the other population. So in such a case, the average sample observation of population 1 we have taken as x1, and the average sample observation for population 2 we have taken as x2. S1 and S2 are the standard deviation of the sample observation of population 1, population 2. This population, if this is a case, in this case, the formula that will apply where standard deviation are unknown but equal is SP n minus 1 into S1 square plus n2 minus 1 into S2 square upon n1 plus n2 minus 1 and the square root of that. Now, to understand in a better manner, let's take an example and understand that how we can calculate or how we can do a hypothesis testing using t-test of two population. You see, an experiment is conducted to compare mean lengths of time required for bodily absorption of two popular insulins, say from company X and company Y. 10 women are randomly selected and given a dose of company X. Similarly, another group of 10 randomly selected women are administered an insulin of company Y. the length of time in minutes for the painkillers to reach or insulin to reach a specified level in the blood is recorded as its sample averages, standard deviation, and sample size has been summarized in table 1. You can see here, and we are testing at alpha is equal to 0.05. Test the claim that the insulins are identical in terms of mean time required for bodily absorption. Now, to better understand this question, we can say that there are two populations. One is the dose from company X, and on the other population, dose for company Y is given. Now, we are trying to test that if the population of this, our hypothesis is mean for the variable under the study of population 1 is equal to the mean of the variable under population 2, whether it is true or not. So we have made it a null hypothesis. What is population 1? Population 1 is the collection of all users represented by the group of 10 individuals who received insulin from company X. And population 2 is what? It's a collection of all users represented by the group of 10 individuals who received insulin from company Y. The common variable under study is the time required for bodily absorption of insulins. So we see the mean of the variable or the mean of the time required for the bodily absorption has been specified as mu1, and for population 2 it is mu2, and null hypothesis HO you can see here is mu1 is equal to mu2, and the alternative hypothesis is that it is both the population are different or their impact is different, and that is what we are trying to test with the help of two population t-test. You can see that first we calculate the t calculated, and the t calculated here it is denoted by a notation, and this notation is delta. The test statistic value is delta here, and it comes out to be 0.6670, and it is the formula is same, T is equal to x minus mu or sigma, or you can use the formula what we have stated n1 minus 1 into s1. So where n and s you already know, you can see the table here where company X and company Y details are given. N1 is equal to 10 and company Y it is also 10, but means are different, and S1 is equal to 8.1 and 7.3. So putting into this formula, you can find out the T statistics, and that is the T calculated, and the T calculated is 0.6670. Now this is the value 7.7104 is equal to x minus mu over sigma, the standard deviation. So instead of standard deviation, we have used this formula denoted by SP, and when we after this we need to look at the degrees of freedom. So looking at the degrees of freedom in the T table, and at alpha is equal to 0.05, you find out the T table value, and since the T calculated is less than the T table value, means that 0.6670 is less than 2.101, we can conclude that the insulins are identical in terms in mean body absorptions, or we can say that we accept the null hypothesis mu1 is equal to mu2. We have a test for two population means, but here the samples are not independent, the samples are dependent. The two samples are dependent if each member of one sample corresponds to a member of the other sample. Dependent samples are known as matched samples or paired samples also. Use of such dependent or paired samples will enable us to perform a more precise analysis because they will allow us to control the extraneous factors. With dependent samples, we still follow the same basic procedure that we have followed in all our hypothesis testing. And the only difference is that what we can understand from dependent sample is that a sample of water of an inlet and a sample of water of an outlet at a effluent treatment plant is tested to measure the effectiveness of an ETP. Now, if we want to test whether the two samples, means the inlet sample and the outlet sample, are the same or the different, then we say that it is a two population means test for dependent sample, because in this, or the outlet water is dependent upon the inlet water. The pollution level of outlet is dependent upon the inlet water. Where we can take another example of dependent sample and see how this hypothesis testing is done. Let's take an example. Two employees perform at a work with music playing. The music was turned on during the working hours of a business with 45 employees. Their productivity level averaged 5.2 with a standard deviation of 2.5. On the different day, the music was turned off and there was 40 workers. The workers' productivity level averaged 4.8 with a standard deviation of 1.2. Now, what can we conclude from this at 0.05 level? So, first of all, solution to this problem. We first develop the hypothesis, the null hypothesis, which says that mu1 minus mu2 is equal to 0, means that mu1 is equal to mu2, or we can explain it as that the productivity of the employees of the two populations, which one population in which the music was playing and the other population, the other time in which the music was not playing, and the productivity of both the population is same. This is our null hypothesis. And the alternative hypothesis is mu1 minus mu2 is greater than equal to 0. It means there exists a difference between the two populations and productivity of one is greater than productivity of another population. We need to find out, again the same procedure we will apply, x minus mu over sigma. So we need to find out the standard deviation. Recall from before, we had the mean of the difference is mu1 minus mu2 and the standard deviation formula, which you can see here. So mu x bar 5.2 minus 4.8 is equal to 0.4. So this we have found out by substituting the sample means and standard deviations from the point estimate of the population means and the standard deviations. So, and the standard deviation we have got 0.405. So what we can conclude here is that putting the values here, x minus mu over sigma, or you can also say 5.2 minus 4.8 upon 0.405, we get 0.988, in which one more example is given, and we can see that how hypothesis testing can be done for this small size of samples. 9 dogs and 10 cats are tested to determine if there is a difference in the average number of days that the animal can survive without food. The dogs average 11 days with a standard deviation of 2 days, while the cats average 12 days with a standard deviation of 3 days. What can be concluded? At alpha is equal to 0.05. The previous example, what we have seen, was of a large sample and this is of a small sample, but almost the procedure is same, and you can see the hypothesis made, and it is again the same type of hypothesis that mu dog minus mu cat is equal to 0 means we assume that there is no difference between their survival time without food between cat and dog, and we are testing that. And for n1 sample size 9 and n2 it is 10, and then their mean and standard deviation is given. We have put up into the formula. We have used this t test, that the t critical value corresponding to alpha is equal to 0.05 with the degrees of freedom 10 plus n plus n1 plus n2 minus 2 is equal to 17 degrees of freedom is 2.11, which is greater than 0.84. Hence, we fail to reject the null hypothesis and conclude that there is not sufficient evidence to suggest that there is a difference between the mean starvation time of cats and dogs. Now we will do a hypothesis testing for proportions, and we have till this point we have done the hypothesis testing for a difference between means, and for this we use a different formula, and this formula you can see here, it is written, and we can use this formula and solve one question to see how this is being done. In this example, in the severity of drug problem in a high school of the same the same for boys and girls, 85 boys and 70 girls were questioned, and 34 of the boys and 14 of the girls admitted to having tried some sort of drug. What can be concluded at the 0.05 level? Now here you can see, again I would say the same procedure, but now we are using proportions rather than means. So here we have assumed that the proportion P1 and P2 is same, and for proportions we have taken out for P1 34 divided by 85. In this we have taken 48 out of 155. That is the proportion 2. So it is putting up in the z-test formula, we get z value or z calculated as 2.68. Since we are using the significance level of 0.05 and it's a two-tailed test, the critical value is 1.96. Clearly 2.68 is in the critical regions, hence we reject the null hypothesis and accept the alternative hypothesis and conclude that gender does make a difference for drug use. And for finding out the conventional way of finding out this p-value, the formula is 2 into 1 minus 0.9963, which comes out to 0.0074, and since it is less than 0.05, it is another way to prove that there is a significant difference between the boys and girls as far as the usage of drugs is concerned. So students, let's now summarize what we have learned in this module. This module helped us in understanding how hypotheses are to be framed and how hypothesis testing is to be done when two sets of samples are taken from different populations. Two sample tests are to be used to reach a conclusion about the relationship between two populations. We learned that the parameters of the sampling distribution, how to estimate the standard error of a sampling distribution. We can also conclude that a pair different test is appropriate when the two samples are being tested on are dependent samples. In testing hypotheses about the differences of two means, suppose that the sample sizes are large, and if we do not know the actual standard deviation of the two populations, we can use the sample deviations as estimates. We also came to know that testing differences between means with dependent samples become one sample test once we compute the differences of the paired observations. Thank you very much.